In the topic of electromagnetic induction, transformer is one of the concepts that can be asked for 5 marks. So, in this question, they may ask you to find out the principle, what is the principle of transformer, what are the different advantages, and then why the practical transformers cannot have 100% efficiency. Now let's begin with the transformer. It is a device which works with alternating current, alternating voltage, and under the principle of mutual induction. So here transformer is a device which can increase or decrease the voltage. Basically the transformers contains two coils. The coil that is connected to AC is called the primary coil, and the number of turns that are attached to the primary coil are represented by NP, where P is the suffix. Now the number of coils that are attached in the secondary secondary coil is NS. Now the transformers are of two types. One is step up transformer and the other one is step down transformer. So in the step up transformer, the number of primary turns NP is less than the number of secondary turns. That means if secondary turns are more, then it is called the step up transformer. Now if you take the reverse of it, if the primary windings are more and secondary windings are less, then we say that it is step down transformer. Now you can see this is a transformer. This is a step down transformer. These are connected to AC mains, and then across this load resistance you can connect any electrical appliance. So this is a step down transformer. So now to begin with, every transformer will have two coils. Now the transformer works with mutual induction. So we have already studied what is mutual induction. Mutual induction means if there is any change of flux in the primary, then there will be some change of flux in the secondary also. So this is the reason why the transformers cannot work with DC, because in the DC the voltage or the current which is steady current. So once the flux is induced or induced EMF is induced in the secondary, and then it comes back to zero because there will be no further change in the flux. Now here in AC what happens? It is changing its voltage in the alternative cycles, both in the direction as well as in the magnitude. Therefore continuous change of flux will be associated with the primary, which is transferred to the secondary. So transformers can work with only AC, alternating voltage. So the principle that you have to stress in this is mutual induction. So transformers work with mutual induction. Now we assume that the flux linked with primary is also equal to the flux linked with the secondary. In practical transformers it is not possible, there is some flux linkage, but to begin with we assume that there is no flux leakage. In that case we can write the formula for the flux of primary as well as for secondary by the help of Faraday's laws of electromagnetic induction. Now you see EP, that is induced EMF related to this primary, is the rate of change of flux, and it also directly proportional to the number of turns in it. So EP is equal to minus times NP d phi by dt, where phi is the flux. Now this NP is indicating the number of turns. So from this equation we can understand the induced EMF is increased when we increase the number of turns. Now similarly we can write another equation, ES, that is the induced EMF in the secondary circuit, is minus NS d phi by dt. Now if you divide 2 by 1, you will get ES by EP, which is equal to NS by NP. Remember, the flux in the primary as well as in the secondary is same. So that's why I did not put any suffixes here as d phi p or d phi s. Okay, now this is one of the important equations in transformers. Now we assume that there is no power loss. That means the transformers work with 100% efficiency. For that, input power must be equal to output power. We know the formula for the power. Input power, voltage times input voltage times input current. So EP IP, which is equal to ES IS. Now from this we can simplify ES by EP is equal to IP by IS. Now from this equation and this equation we can conclude that ES by EP is equal to IP by IS, which is also equal to NS by NP, and this is only known as the transformer ratio. Now this transformer ratio, when it is greater than 1, we call it a step up transformer. You can see this one here, NS by NP is more than 1 because number of secondary coils are more than that of primary. Now if K is less than 1, that is called step down transformer. Now practically the efficiency of the transformers is up to 90% only. Why? Because there are some power losses while transmitting the power from one place to another place. So how actually a transformer can transmit the power from one place to another place? We know that power is equal to I square times of R. Now if you can reduce the power, if you can reduce the current, then automatically the power losses will be reduced. So transformer can do that by stepping up the voltage such that, as we know that EP IP is equal to constant, therefore by raising EP, that is stepping up this induced EMF, then automatically the current can be reduced. So this is one of the major applications of the transformer, by virtue of which the alternating power supply can be transmitted from one place to another place without any power losses. So this has revolutionized the American economy, not only the American economy, the world economy. So if you estimate the cost that is required to produce DC and to transmit is very much higher when compared to the expenditure incurred in transmitting the alternating voltage. Therefore transformers play a vital role. Now what are the reasons that the practical efficiency of the transformer is 90? So for that, first we have to discuss the flux leakage. As we have discussed, there is no leakage of flux, but still there is some leakage as the windings are not properly wound over. Now to reduce this flux leakage, we have to take only one core over which the two can be wound. Now here this blue color is indicating the primary, the red color is indicating the secondary. Normally the transformers are wound like this, but if you can on the same core, if both are wounded, then automatically this flux leakage can be minimized. Now the other one is we are using many wires in this transformers. So this internal, if you go through the internal structure of this one, then automatically there will be copper wires. So these copper wires, when current is passing through it, already we have discussed, it is I square R is the power loss. Now we have to reduce this resistance. So if you want to reduce the resistance, then we have to make use of thick wires in winding. So resistance of the winding of the wires cause the major loss, and that can be reduced by using thick wires. Now the third one is eddy currents. We have already discussed eddy currents, which are also known as Foucault currents. These currents are caused because of change of flux. Already we have discussed this works with the mutual induction. Therefore change of flux must be there with the transformers. So as change of flux is continuously associated with the transformer, the eddy currents are generated. Because of generation of eddy currents, the heat is produced. So this is one of the losses caused by this transformer, this can be minimized by a laminated core. The fourth factor which reduces the efficiency of transformer to 90% is hysteresis losses. What are hysteresis losses? In this, continuously the iron core gets magnetized and demagnetized, and if you observe the hysteresis loop, this loop whose thickness is very small, the hysteresis losses are very small. If the thickness is more, then the hysteresis losses are more. So to minimize this hysteresis losses, we have to select a substance whose loop is very thin. So in that way we can minimize these losses and we can raise the efficiency of the transformer. So in this topic we have discussed what is transformer, how it is applicable or how it is applied only to AC, not to DC. Then what is the principle behind it, that's mutual induction. Then we have derived one expression for transformer ratio which is K, and we have also discussed step up transformer and step down transformer and different losses caused by the transformer while it transmits the power from one place to another place. The problems can be asked based on this. If you remember this formula, then he may give you the input primary EMF and secondary EMF and primary current and they may ask you to find out IS, or otherwise if you remember this formula, out of this 3 may be given and fourth one can be asked. So sometimes they may ask you to calculate the power loss, there you have to calculate I square R. So these are the different concepts that we have to give stress while writing the answer of transformer.